Hi friends, in this video we'll discuss about particle swarm optimization using CPP language. First we'll see the invention of particle swarm optimization. Particle swarm optimization was developed by Dr. Eberhard and Dr. Kennedy in 1995. James Kennedy was a researcher at the Kennedy Space Center and Russell Eberhard was a graduate student at Florida Institute of Technology. PSO was developed as an optimization algorithm that is inspired by the social behavior of bird flocking and fish schooling. Now we'll see the basic idea and introduction of particle swarm optimization. Particle swarm optimization is a population-based optimization technique used to solve various optimization problems. It was developed by Kennedy and Eberhard in 1995. The algorithm consists of population of particles that move in the set space to find the optimal solution. Each particle represents a potential solution to the optimization problem, and its movement is influenced by its own best known position and the best known position of its neighbors in the set space. The particles move towards their own and their neighbors' best positions while exploring the set space. The PSO algorithm, with an initial population of particles randomly distributed in the set space, each particle is evaluated using a fitness function that measures the quality of its solution. The movement of each particle is determined by updating its velocity and position uh, in each iteration. Now we'll see the basic idea of particle swarm optimization. Now we'll see an example. When a bird is flying and searching randomly for food, all birds in the flock can share their discovery and help the entire flock get the best hunt. When one bird locates food, it instantaneously transmits information to all other birds. Then all other birds start to search in that proximity for much more food by altering their velocity towards the direction. This is the pictorial representation of particle swarm optimization by fishes and birds in daily life example. Now, how particle swarm optimization is used for multi-dimensional optimization problems. In multivariable optimization problems, the swarm flock of birds is assumed to be a fixed size with each particle located initially at random locations in the multi-dimensional space. Each particle is assumed to have two characteristics. Number one is position and number two is velocity. Each particle wanders in the design space and remembers its best position it has discovered. The particles communicate with each other and adjust their positions and velocities based on the information received on the good positions. Now we see the algorithm of particle swarm optimization. We'll assume the size of the swarm, which is number of particles is n. We'll generally prefer of 20 to 30 particles. We'll generate the initial population of x in the range x of L to x of u randomly as x1, x2, so on xn. The position of each particle and its velocity in ith iteration are denoted as xi of j and vi of j respectively. Thus, the particles generated initially are denoted x1 of 0, x2 of 0, so on xn of 0. The vectors xj of 0 are called particles or vectors of coordinates of each particles. Now we'll evaluate the objective function values corresponding to the particles as f of x1 of 0, so on f of xn of 0 for n particles. Now we'll find the velocities of each particle. All particles will be moving to the optimal point with a velocity. Initially, all particle velocities are assumed to be 0 in the first iteration. In the ith iteration, we'll find the velocity of each particles by using this mathematical representation, where C1 and C2 are individual and social group learning rates, and R1 and R2 are uniformly distributed random numbers in the range 0 to 1. The parameters C1 and C2 denote the relative importance of the memory of the particle itself to the memory of the swarm. The values of C1 and C2 are usually assumed to be 2, so that C1 R1 and C2 R2 ensure that the particles would overfly the target about half time. We'll find the position of each particle in ith iteration by using velocity of ith, ith particle in ith iteration. Now we'll check the convergence of the current solution in the if the positions of all particles converge to the same set of values, the method is assumed to have converged. If the convergence criterion is not satisfied, the above step is repeated by updating the iteration number as I is equal to I plus 1. And by computing the new values of P best and global best, the iterative process is continued until all the particles converge to the same optimal solution. Now we'll see the CPP implementation of particle swarm optimization. First we'll create the particle class and then we'll initialize position and velocity randomly. After that, we'll initialize best position to current position. Now we'll evaluate fitness at initial position. We'll update particles position and velocity. And we'll update velocity by using velocity, we'll update position by in ith iteration. Now we'll evaluate fitness at new position. Now we'll give particle swarm optimization parameters, which is given by input. In this one, have taken number of particles as 123, dimensions as two-dimensional problem. We'll do maximum iterations up to 100. In the C1 and C2 are assumed to be 1. We'll find the global best position and we'll run the particle swarm optimization code. We'll update the global best position in each iteration. We have got global best fitness values as 1.48843 in this example. Now we'll see the applications of particle swarm optimization. Function optimization. PSO is commonly used to optimize functions that are difficult to solve using traditional optimization methods. And PSO is used in machine learning. PSO is used to optimize the weights and biases of artificial neural networks. And PSO is used in control systems. PSO is used to optimize control parameters for various systems, including aircraft, vehicles, and industrial processes. And PSO is used in transportation. PSO is applied to optimize the routing and scheduling of transportation systems. Next, we'll use PSO in image processing. PSO is used for image segmentation and image registration and feature selection. Now we'll see the disadvantages, which is known as limitations of particle swarm optimization. Number one is there is a high chance for the result to converge to a local maximum minima, which will be a problem if the target is to find global maximum minima. Even though the number of particles and number of iterations are more, we won't be able to set every point in the design space, which consists of infinitely many points. But the result is very close to the exact solution. Thank you.